All right, so in this lesson, actually, we're going to explore matrices and its applications. So problem one is this. For the matrix A containing elements 2, -1, 3, and 4, calculate the inverse of A if it exists, or calculate A raised to the power of -1. It means inverse of A. Now, basically, we can calculate the inverse of any matrix if it is a square matrix and the determinant is not equal to 0. If the determinant is 0, we cannot get the inverse, or if the matrix is not square, we cannot get the inverse either. When I say square, it could be 1 by 1, 2 by 2, like our matrix here, 3 by 3, and so on. It means the number of rows is equal to the number of columns. So the given matrix here actually is a square matrix because we have 2 rows and 2 columns. This is row 1. This is row 2. This is column 1 and column 2. Okay, so the first step actually is to find the determinant. Our det A is equal to the left diagonal. That is 2 times 4. And in the middle is always minus -1 times 3. So it means that we're going to multiply the left diagonal elements 2 and 4 minus the right diagonal elements -1 and 3. So here our answer actually is equal to 11 because we have 2 times 4 is 8 and we have plus 3 because this is negative and negative. The next step actually is to find the elements, the position of every element. So A sub 11, that means row 1, column 1, that is 2. And row 1, column 2 is -1. And row 2, column 1, 21 is 3. And row 2, column 2 is equal to 4. Right? The next is to use the formula. The inverse of any 2 by 2 matrix actually is equal to 1 over determinant times, we are going to swap these two. So this will become A sub 22 and this will be A sub 11. A sub 12, A sub 21 will be in the same positions, but this will be reversed, the signs here. Okay, because we're getting the inverse. Again, we will swap A sub 11 and A sub 22. So we're going to swap that. And A sub 12 and A sub 21 will be in the same positions, but we change the signs. Okay, so our inverse is equal to 1 over 11. That is our determinant times, we're going to swap now our A sub 22 and A sub 11. So this will become 4 and 2. -1 will become 1. And 3 here will become -3. Okay, so here we have the final answer. We multiply 1 over 11 and 4, that becomes 4 over 11. And here we have 1 over 11. Okay, that is 1 over 11 times 1 and -3 over 11. That is 1 over 11 times -3 and 2 over 11. In decimals, the answer are, here we have 0.3636. Okay, here 0.0909 until infinity. Here -0.2727. And the last one 0.1818. Okay, that. So these are the elements of our inverse. All right, so Let's proceed to problem number 2. Here you're going to find the determinant of the matrix. As you can see, this matrix actually is square, 3 by 3 matrix, because we have 3 rows and we have 3 columns. Now to get the determinant, actually, what we're going to do is just to use column 1 or row 1. Okay, but it's easier to use actually our column 1. Okay, so how are we going to do it? We have plus minus plus. This is how we're going to proceed. It means the first element in column 1 will be positive. So this is positive 2. We copy our matrix. We have 2, 4, 7. And then we have 3, 0, 6, 1, 5, and 2. And the second is negative. So it will be negative 4. Then we copy again our matrix. Plus 7. Because we have plus here. The last element in that column, we copy again our matrix. Okay. The next is to cancel some values. We're going to start with the first element. Here, the first element is 2. So we're going to delete left to right and up and down. So the remaining is 2. Positive 2 is 2. We have 0, 5, 6, and 2. Okay. And here we have minus 4. We're going to encircle 4, this number. Okay, left to right, up and down. The remaining is 3, 6, 1, and 2. Then the last is plus 7. Okay, we're going to encircle 7, left to right, up and down. So the remaining is 3, 1, 0, and 5. So we're now going to get the determinant here actually. Okay, inside, so this is 2 times 0 minus 30. That is 0 times 2 minus 6 times 5. Minus 4, this is 3 times 2, 6. 6 times 1, 6 also. Plus 7, 3 times 5 is 15. Minus 0 times 1, here is 0. Always we start with the left diagonal. Okay, always left diagonal first, minus the elements in the right diagonal. So the answer here is 45 actually. Here we have negative 60. Here we have 0. 6 minus 6 is 0. This is 105 minus 60 is equal to 45. Okay, so this is how to find the determinant